Swayam Prabha. Digital India. Educated India.
So, we are back with lecture 4, module 3. In this section, we will try to see the glass wall fixing, because we are left over with the glass wall fixing, and the other is the glass as an insulating material. So, we had looked into the various ways of glass fixing in the previous lecture. Prior to that, we had seen the different types of glass. Prior to that, we had gone into the what is glass, how it is obtained, etc. So, now we had already exposed you to the glass wall in the previous lecture, where we discussed that is glass block which is being fixed one after the other to form a wall. Now, what is there inside? Is it like brick masonry, putting some mortar, sand and cement mix, or is it something else? Let us know that. After that, we will go to glass as an insulator, and we have two more interesting things which are using of glass fibers, which is also used in the insulator as a reinforcement for both gypsum as well as plastic. So, let us start with the glass block, which we had already learnt in the previous, I think in lecture 3, where we said that if you have two pieces of glass which are brought together, molded out, and they are brought together and fixed together, and it is joined, that gives a obscure view on the other side. That means you can see some image on the other side, but you cannot make out what is there, or it is not giving you a transparency. It is a kind of translucent view which is obscured. The glass block fixing is visible and is little different from the masonry work. Why? That is why I am bringing this fixing detail. It is used usually as a partition wall in between two spaces. So, this is mostly internal application, not much of external application like that of the spider web joint and the glass facade. This can give a grand look. At the same time, you can have a feel of what is happening inside, and you are not actually getting associated with what is happening inside. So, in the glass block system, locking system, it is the mortar which is pre-mixed blend of Portland cement, sand and chemicals. Here sand is very fine sand, and it may be Portland cement, lime mortar. What is important here, unlike brick, here there is no absorber for the water component. Glass is not at all an absorber of water. Water absorption is 0. So, the water absorption being less, the mortar should be stiff, and to improve the mechanical bond at the edges, it may be coated with polyvinyl butyryl or PVB, or even latex paints. Later we will have a chapter on paints, so let us not bother on this, but we can improve the mechanical bondage between the glass wall and the adjacent wall by coating with PVB or latex paint. Steel reinforcements may be pushed in the mortar, embedded in the mortar to make it more strong. These glass blocks are actually, if you recollect from the previous lecture, they are having partial vacuums inside it. It is air inside it partially. So, these are very much equivalent to the double glazing unit. It is sealed when the two molds are joined together two parts are joined together, it actually locks in the air and it acts as a DGU. Sometimes windows are also made of glass blocks. If somehow you can infill argon, further thermal resistivity can be achieved. However, these have more of applications in countries which are very cold, where they are facing minus 20 to 40 degree centigrade temperature, whereas you have to maintain the inner 23 to 26 degree positive temperature. So, there actually these kind of windows are also effective. After knowing this glass wall fixing system, let us move to the glass wool, where glass works as an insulator. Here you can see in the schematic diagram that some blue lines are actually coming out from a heated plate, and on top is some molten glass. Here you can see a nozzle which is actually spraying air at a very high speed. Here you take a note of the temperature, it is at 1450 degrees centigrade coming out from the furnace, and this is a kind of mesh through which these thin strands are coming out, which are of the order of 4 micrometer to 15 micrometer. It is the diameter, and they are actually spun by a rotating spinning head, and subsequently gradually they are being cooled in contact with air. So, you have a gathering spool, a connecting spool. So, it is a diagrammatic representation of the entire process, and what you eventually get is very fine strands of glass. So, the glass which was cast as plate now has been transformed to fibers or wool like. They become glass wool when they are arranged in a particular fashion, and you can produce in rolls or in slabs, which are also called as bats. These are non-combustible and also recyclable like the other glass. Now, in this picture you can see the glass wool here. This is how it looks. What is there entrapped? It is the air which is entrapped, which is actually helping in the insulation process. So, this entrapped air is the player of insulation. It should be dry. If there is water inside, it no longer serves as a thermal insulator. It also acts as an acoustical absorber. And you can see here the values. Thermal conductivity value of glass wool is of the order of 0.023 to 0.04 watt per meter Kelvin. These can be used for acoustical absorbers also in forms of infills in walls or ceilings. However, if you see the person who is installing, his hands are covered with glass. If you can see a picture image of a person who is seen totally, you will see he is wearing glass protecting his eye, wearing a mask with his nose and mouth being covered, because these thin strands of glass, if inhaled, creates a lot of problem, lot of health issues. So, this is having the negative, that is the negative part of it. Otherwise, it is an excellent material for being used as a thermal as well as an acoustical insulator or a sound insulator. Now, let us see, apart from the application of it in bat or roll form in thermal or acoustical insulation, we can actually use this glass fibers as a reinforcing material in gypsum. But here if you notice the value highlighted in red, you can see here the diameter of the thread is more. That is called roving, a process where filaments are spun in larger diameters of threads. So, you can actually insert these kind of rovings in gypsum. Even then they will remain lightweight. Panel weights are, you can see, 44 kg per square meter and made from obviously gypsum as the major thing and the glass fiber rovings. You have some binder as cement or the thing that will attach it. You need some water and some waterproofing chemicals. So, with this GFRG, what can be done? You can get continuous sheets of 12 meters, 3 meter in height and 125 millimeter in thickness. So, it is a kind of wall which will be having gaps, hollows. I will show you a section. And this glass acts as a reinforcement there. So, it is hard, it is tough, it can take impacts. These hollow spaces you can actually plug in with reinforcement if required or plain cement concrete if required to give it more rigidity. Otherwise, you can use it as a partition wall within a building system. The hollows also allow pipelines etc. to move, but we are not more interested into that, but we are more interested into the glass strands, which is actually giving it a compressive strength of 7 Newton per square millimeter when hollow. U value, it has given 2.85 watt per meter Kelvin and it has also given a fire resistance up to 1000 degrees centigrade temperature. It is a green building technology. It reduces lot of carbon dioxide and is compared to conventional panels, and it has been also approved by the United Nations agency. How does it look? Here is the panel. Here is the cross section where you can see this is the hollow. It is 250 millimeter where it is having a rib strengthening the item. You can see the cross section here. So, at every 0.25 meter, that is 250 millimeter, there is a rib which is strengthening the wall, and the glass rovings are being mixed with the gypsum and it has created the two ends and also the ribs. This is an enlisted material by the Central Public Works Department. It is in the specification and it has been promoted by our Building Materials and Technology Promotion Council, that is BMTPC manual has this kind of, all the details of this particular material. We will discuss it little more when we go into prefabricated items. The other is glass fiber reinforced plastic, that is GFRP, which is made with thermosetting plastic, which we will later on explain. Glass fiber as the reinforcement, these are the glass fiber rovings. Resins are the binders here, and you also can have additives, coloring agents, etc. How do they look like? Like this. Here you can see the fibers are aligned. Which fibers? The glass fibers. So, the glass fibers are in one particular direction. These are having one unidirectional strength reinforced. You can have woven fiber where the strength is in both the direction. You can bend it this way, you can bend it this way, because it is ultimately going into plastic. Now you see in this unidirectional, the aligned fiber, you see this is having the waviness or the corrugation. The corrugation is in the direction of the glass fibers. It is not in the opposite direction. But with the woven fiber, you can have in the corrugation in any direction, or else you can use as a plastic sheet, reinforced plastic sheet, glass fiber reinforced, or else you can have the random fiber, where you can see the glass rovings being seen, they are randomly spreaded in different directions. So, these are again lightweight, translucent, heat resistant, strong building material, used as a roofing, used as a sheet, used for temporary structures, used for cycle shed roofs. So, we do not stop exploring glass. You have seen many application of glass other than the way we see glass in our day-to-day life only in windows or maybe in the washroom louvers or maybe in schools, colleges, institutions. Yes, that is the major part where we are using. But whenever we are looking into glass, whenever the researches are being explored, we can find the use of glass is happening in various domains. So, we can see that glass has a versatility and we are getting newer applications. Glass is nowadays used as insulation material, structural component, external glazing material, cladding material, other than the conventional windows and the delicate looking fenestrations of on the facades. It is undergoing transformation and we are finding its use in solar power glass, in switchable glass, that is the e-glass, where you can keep on changing the translucency value and you can change the entry of solar energy inside the building. So, these are all applied in intelligent building systems. So, with these I conclude the part of glass, that is up to lecture 4 of this module, and in the last lecture we will go into the ceramic tiles and the vitrified tiles which have a glass coating which is glass like, and we will close the module. Thank you.